The last time, marriage counseling problem, the claim was that counseling doesn't work in increasing happiness. 1 means not happy at all, 10, very happy. So we had the data before, after, we've recorded the happiness levels based on 8 patients. ZI after minus before, we had the differences. Now we have to do psi I. Positive, yes. So 1, 1, 0, 1, 1, 1, 0, 0. Yes. So positive sign, positive magnitudes have 1 assigned to them. So the test statistic is the sum of all the psi i's, which is nothing but the sum of 1s. Do we agree? So 5. Good. Now, last time, what was our alpha?
I think we did 0.1 for the 2-tailed.
0.1. Okay. So we are performing a 2-tailed test. The null is that the location is in the middle, no difference at all. Alternative, that is not the case, not equal to 0. Since this is a 2-tailed test, we have a rejection region on the right, we'll have 1 on the left. So we have to find the critical value, the exact critical value. So we have to use the exact distribution and not the approximated distribution. So this time we've got to use the calculator just like we did with binomial test. So first step is to put it in the calculator. So list 1. So we have values from last time. So clear list.
Where's that clear list, by the way?
Option 4. When you press that, option 4.
Okay.
Go to L1.
Yeah, you can also just go to L1 on the list.
You can.
Either.
I like it this way
Sorry.
because I'm special. Okay, so N in our case is A. So 4, 4, 8. If N is A, what are the possible outcomes? Huh? 0 through 8. So 0, 1, 2, 3, 4, 5, 6, 7.
Is that 9 number now?
Yeah, because we're measuring the number of successes. So 8 numbers here. You can have no successes at all, exactly 1, exactly 2, all the way up to exactly 8. So you would have 9 numbers. 0 through 8. Good. Second verse. We've got to do the PDF. So what is N? 8. What is P? P is the probability under the null, which is 0.5, comma, second 1. Okay, so we've got to keep on adding on either side so that we get less than or equal to what value in this problem. Alpha is 0.1, so we've got to keep on adding like we did with binomial test. The left-hand side until we hit what value? It has to be less than or equal to
0.05.
0.5,
0.05.
0.05. How did we get 0.05?
Half.
Alpha over 2. Why alpha over 2? Because I told you at this problem that we worked as a two-tail test, or two-tail test, we've got to divide alpha by 2.
When you were telling to divide up, you put 0.5 instead of 0.05.
It is 0.5 up there because the distribution is n, p, x. N is 8, p is 0.5, x is 0 through 8. But 0.05 is alpha divided by 2. They are different things.
Oh, so we're just supposed to assume that he's 0.5 here?
Yes, because under the null, if there are no differences at all, you have half of positive signs, half of negative signs. Do you agree? If counseling did nothing at all, out of 8 people, 4 benefited, 4 did. Yes, so 50-50, so P is 1/2.
So it was 8.5, and then what was the third part?
L1.
L1, yeah, sorry.
So we should keep on adding all the way up to a point where we hit less than or equal to 0.05 on the left-hand side. Right-hand side, allowed to keep on adding from A, go below, until you hit 0.05. But in this problem though, I don't have to do that. Why? So I don't have to look at both sides. Let me do this and perhaps it will click. So where should I start? Starting at 0, I'm going to keep on adding the probabilities until I am less than or equal to 0.05. Should I include 0? Yes. When I add the probability of 0 to 1, I get 0.03125. Should I make the critical value 1 now? Yes, when I add these two numbers, the result is still less than 0.05. Can I move the critical value to 2? No, because when I add, it exceeds 0.05. So the critical value on the left-hand side has to be 1. Now, let's go to the right-hand side. I have to start at 8 and go below. Should I start with B alpha over 2 to be 8? Yes or no? Is it less than 0.05? Yes, sure. But can I reduce it to 7? If I add the probability of 8, which is 0.00391, to the probability of 7, which is 0.03125, that value is still less than 0.05. Do you agree? Can I move that critical value to 6? No, because the moment I include 6, alpha over 2 now becomes a value over 0.05. So no. So the right-hand side has to be 7. Yes, this is exactly what we did with binomial test. 1 second. But I didn't have to do this side at all. I could have simply did one of the two sides. Can you tell me why? Chris is absolutely correct because it is symmetric. If you look at the probability values, the value from the left and the value from the right going below are one and the same. Yes? Now, what makes the probability distribution symmetric? When we did binomial test, I stressed this point. There is only one case when binomial distribution will be symmetric. What is that one case?
When P is 1/2.
When P is 1/2. That is the only time. since our P is 1/2, it is symmetric. So I don't have to find both. If you look at 7, 7 is simply n minus 1, correct? So B alpha over 2 is simply n minus C alpha over 2. You find one, you can find the other. Likewise, C alpha over 2 is n minus B alpha over 2. Good. You don't have to find both, unlike a binomial test. One of them is good enough. But as Gunnar pointed out, this is the alpha that we went after, 0.05. But what is the alpha we achieved? We actually achieved a value that is less than 0.05, correct? So this critical value is an approximate. So what does it belong to? It actually belongs to the sum of 0.00391 and 0.03125, which after 3 decimal places would result in 0.035. I'll call it exact alpha is 0.0325. Actually, alpha over 2. That is our alpha over 2 matrix. Did we call it as alpha star? I don't think so. Of course. Yeah, we
We
did.
had some star, or is it C star?
Yeah, the star, we used it for the approximation. But do you see what the exact alpha is? We were trying to get to 0.05, but we stopped at the sum of 0.003 and 0.035. So that is the alpha over 2 we achieved. If you multiply by 2, the exact alpha in this problem will be 0.07. Good. That is well below what we wanted, 0.1. Good. Now, we know the rejection region. On this side, it is 1. That side, it is 7. Where is the test statistic? Well, our test is go ahead, Kate.
5, so false.
So 5, it falls somewhere over here. Should we reject a null? No. Test statistic does not fall in the rejection region. Since it doesn't fall in the rejection region, should we reject the null? We shouldn't. Oh. So do not reject null. If I do not reject null, what is our null statement? Theta is equal to 0. Yes. Theta corresponds to the differences. How did we define our difference? We defined our difference at the beginning of the problem as after minus before. So theta describes after minus before. If after minus before is equal to 0, it would imply after is equal to before. Agree? So the happiness after counseling is the same as the happiness before counseling. It simply implies that counseling does not work. This is artificial data, people. Don't go complain to a psychologist. I made this up. So based on the artificial data, the claim is true. But then though, if a marriage is, destined to fall apart, it will. Nothing can help, right? But how do you know? That is the bigger question. The psychologist might help you figure that out. So in this case, with the artificial data, the claim is true. Good with me? The next step is to find the p-value. But I have to use the calculator anyway, so start number one, we had the values. So I added 0 to 1, right? The probability of 0 to the probability of 1, so 0.00391 plus 0.03125 would be approximately 0.03526. I kept it as 0.035.
Okay.
So to find the p-value, we have to come up with the area above and below the test statistic. The area above the test statistic we can find using what distribution again? What is the null distribution? Huh? Not the last half in this case. What should we use?
We should use binomial.
We should use binomial. So we use the PDF function to find the critical values. To find the p-values, what function should we use? The highest.
Yeah, binomial PDF.
PDF or CDF?
I mean,
Yeah.
yeah.
CDF. So second part.
Yeah, because there's a p value.
So number or option B. So number of trials, probability of success, X, that will give you the PDF exact probability. To get the CDF, you do the same thing. We want to find the probability of less than, should we do this side? Let's do this side. So the right-hand side is simply the probability greater than or equal to 5. Yes? For a two-tailed test, you take the area above the test statistic, add it to the area below the test statistic. Yes, no, maybe. That's what we've been doing. But normal, we did 2 times the area above the absolute value of the test statistic, which is pretty much the same thing. We just made it easier. So I want to find the area above and I want to add the area below, but you've got to be careful. Area above, area below, you add the two, what do you get?
It's gonna be the same. Well,
It-
yeah.
When you add, you're adding all values. So what would you get? It'll sum to
Wow.
1. That wouldn't make any sense. So if on the right-hand side, the test statistic is 5, what do you expect on the left-hand side as a test statistic? In other words, if I flip the signs, what would I get? The number of negatives, right? How many do I have? 2. 8 minus 5, 3. So on this side, it's 3. Yes, number of negative signs. So you can find the area above the test statistic, area below the test statistic, add them together. But fortunately, this is, of course, it's n minus t, 8 minus 5, we get 3. In this case, I don't have to find both. Why?
We can double one. We can double.
Why? Why?
Because in this case, it's symmetric.
It's symmetric, so I can double just like I did without the question. Okay, so it's symmetric, so I find one, I can simply multiply. So the calculator always gives you a less than or equal to probability when it comes to binomial CDF. That's just definition of a CDF. So I recommend that you always find this and compute the other value. So in this case, we have n to be 8, a 0.5, and the value of x is 3. Multiply that by 2. Why? I'm adding the area below and area above. I end up getting a p-value of 0.7265. So if you concluded our result, and excuse me, if we ignored what the test suggested, and you said counseling is beneficial, the probability that you would be making a mistake will be approximately 73%. Should you make that mistake? No. According to the artificial data, counseling is useless. Artificial. Okay, that said, what was the Wilcoxon p-value from last time? For the two-tailed test. Mind you, we started this problem with the data that we had from Wilcoxon Sandbach. What was its p-value? Come again? That was after we multiplied by 2.
See the multiply by
Yeah, we didn't multiply.
Why did we not multiply by 2?
Because that was the added.
No, that is the added
That is the
values.
added
Okay,
value.
okay, I see. The added values, that's what I meant, not multiplying.
my code.
So you can see the probability here is higher than the Wilcoxon Sandbach. So the chances you'll be rejecting here is strict, more strict compared to Wilcoxon Sandbach. So a Fisher sign test is being very conservative compared to a Wilcoxon Sandbach. Okay, if it is an actual case, we would do both. But a direct comparison here is not feasible because we had ties in the last case. Now, those cannot occur with Fisher tests. So we are ignoring, how many observations did we have? 3 that were tied, right? So technically, we're doing this test with the Fisher with 5. That's what I should be doing if I want to make some sort of a comparison. So now do you see how the two tests differ? So Fisher typically is more conservative in terms of rejecting, but you do have to keep in mind here we ignored the magnitude, unlike Wilcoxon Sandbach. So in that sense, Wilcoxon Sandbach is slightly better than Fisher sign test. This is very convenient and easy. Let's compare to that test. Okay,